Welcome to the SQL Tips webcast, spanning the clouds, high availability and disaster recovery in modern IT for SQL Server, sponsored by SIOS Technology. I'm Greg Robity, co-founder of SQL Tips and the host for today's webcast. Joining me today is Joey D'Antoni. Joey is a SQL Server MVP and a senior architect with over a decade of experience working in both Fortune 500 and small firms. Also joining us is Dave Birmingham from SIOS, who's a cloud and data center management MVP. Today, they will share their knowledge about protecting SQL Server using the cloud. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls, and we'll try to answer as many questions as possible during today's webcast. Also, if you have any technical issues with the sound or screen quality during the webcast, use the question area to let us know as well. If you're not already a member of the MSQL Tips community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, watch videos, and post your SQL Server questions answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Joey, and he can get started.
Thanks, Greg. Today's webinar is called Spanning the Clouds, High Availability and Disaster Recovery in Modern IT, but we're really going to talk about some fundamental things up front. So I'm going to talk a little bit about high availability and disaster recovery and what those mean and how we could configure things. Because as much as I love to talk about technology, and don't worry, there'll be a lot of technology in this talk, these things are really process things as well. So it's not just a specific technology we need to think about. High availability also includes things like how you do code releases and things like that to make sure you're not doing things in a manner that lead to breaking changes, because as we know, breaking changes are always bad. So if you're new to the cloud or you're new to clustering and you have any questions, just put them in the questions pane and I'll try to answer them as I go. Like Greg mentioned, I'm Joey D'Antoni. I'm a principal consultant at Denny Associates Consulting. I'm a data platform MVP now since Microsoft changed our branding. I'm an MCSE for Business Intelligence and Database Administrations, and I'm also a co-author of an ebook that just came out from Microsoft called Introducing SQL Server 2016 Mission Critical Applications, Deeper Insights, and Hyperscale Cloud. We just finished writing 2 more chapters, so that book is kind of getting released as the CTPs for SQL Server get released. So there'll be more content every month, so you can keep an eye out for that. I blog at joeydantoni.com. I've got a lot of topics there in HANDR and some of these cloud configuration things that you'll run into that are unique. You can find me on Twitter at jdanton, and if you have any questions after the fact, that's probably the best place to reach me. I'm pretty good at reading Twitter. So high availability. A little bit about high availability. There are 2 things I like to think of about high availability solutions. One of which is hardware failure. So in this case, the complete meltdown of a server rack, or a server rack that kind of had a little bit of a heat problem, as we like to say, or the complete meltdown of a server, so operating system failures, the blue screen of death. Sometimes you can have this be some combination of the 2. I've had memory fail and lead to blue screens of death. Fortunately, it was in a cluster, so my downtime is minimal. One of the things you want to think about from a high availability perspective, and this is going to play into the cloud a little bit, is your strategy. So virtualization gives you some degree of high availability, but it's typically not going to protect the transactional integrity of your SQL servers to an degree that SQL Server will. And you may or may not have OS protection. So if you're really looking to go in towards 4 or 5 nines, you're going to want to add something on top of just having a virtualization layer. The Microsoft guarantee for availability for infrastructure as a service is 3 nines, so 99.9. So you'll want to look to extend that using other mechanisms for data protection. So this is how Wikipedia defines HA, and I think it's a nice thing about system design, approach, and associated implementation to meet a service level agreement effectively. One of my favorite, in my mind, high availability is generally speaking in a local environment and doesn't provide disaster recovery. One of my favorite horror stories from an old job was I was on call one Sunday morning Uh, and this was a really big Fortune 500 pharmaceutical company. We had really robust hardware and process. It was a pharma company, so believe me, we had process. The FDA wants you to write down everything. But we had a lot of really big, highly available systems, clusters, VMware clusters. We had some Unix-type clusters that were HP machines that provided additional uptime. And I was on call on Sunday morning, and fortunately this isn't too bad of a horror story for me anyway. It was like 9 a.m. And the pager goes off, and I see that a database is down. And this was an Oracle database, it wasn't SQL Server. So I logged onto the Unix box, and where I would have expected to see, a prompt with the current directory I was working in, there was just a number sign. And when I went to try to take a look at the file systems where my databases should have been, they were gone. And I was like, wow, this is a pretty bad problem. I don't know what it is, but there's no way I can database backup. And this is a highly available system. Remember, it's on a cluster, so it should be protected. So I call my boss and I say, hey, I don't know what's going on, but I can't get this database backup. Well, she calls me and she said, oh, I'm sorry. Our storage provider came in to decommission a SAN, and they took the wrong one. And they wrecked the original. So about a week later, we got everything back. So even with the moral of this long story is, even with high availability, there tends to be a single point of failure at the storage layer. It's pretty common in most clustering solutions and most virtualization solutions, and this is why these solutions provide high availability and not disaster recovery. So be sure you don't confuse the two. You want definitely a second layer of data protection. The other thing you're going to want with disaster recovery is some geographical protection, and this is going to apply whether or not you're in the cloud or on-prem. And I've always cared a lot about disaster recovery. I think a lot of that started because I grew up in New Orleans, and my first database job was at the electric utility company there. And electric power is something that's really critical and always needs to be on. So I started learning about DR solutions early. That was in the mid-90s, and we had some pretty advanced stuff. We had multiple data centers. The data center in the New Orleans area was on the third floor and had no windows. So they stayed up during Katrina. Their service restored after that, not so good. But and then after that, I moved on to work in vaccine plants, but I was in North Carolina and Puerto Rico, two places that are very much in danger of hurricanes. What both of those positions really taught me was the importance of a well-written, clearly defined disaster recovery plan, and not this. Every company, no matter how big or small, and really, realistically, it's not just at a company level, it's at a business system level. So I know many of you are DBAs and you have some influence on this, but this is where you really want to go back to the business teams that you work with and say, hey, what's your DR plan in case of a failure? It doesn't mean you have to have a very expensive real-time solution. Those are fantastic, and we'll talk about how to implement them. But a perfectly acceptable plan is to say, in the event of this disaster, we will proceed with that application X, but we need to have application Y online within 2 hours because it's our business. The other thing a lot of people fail to think about when they're planning for disaster recovery is not just technology, it's people and hardware and software resources. So, where's your install media if you have to install to a new box? In the event of a natural disaster, where are you going to locate your employees? Especially in a hurricane area, your employees may all be evacuated, and are they going to be able to deal with trying to bring systems online? So do you need to have some secondary ad source staff? These are all things you want to think about in a plan. And these are the keys to good uptime, no matter your solutions. So you really don't want that Dilbert-esque disaster recovery plan. Just something to think about. So I talked about this a little bit earlier, but just kind of a reminder as to in this simple, basic SQL cluster environment, and this is our traditional SQL cluster with a SAN. I do a lot of presentations on clustering, so I'm pretty experienced. But I once heard a customer say that we don't need to take backups because we have a cluster, which is like one of the absolute worst things I've heard ever. A customer say. That was kind of scary. SQL clustering and clustering in general is a high availability solution. It's rock solid. It's great to implement. We'll talk about how to make it a DR solution, but the traditional model of it, where you have 2 cluster nodes and a SAN, or even more cluster nodes than that, is not a DR solution. The major point of failure in this is that you have a single point of failure. The main solution to avoid this is that we're going to talk about later is SIOS Data Keeper. That's a really nice way to do it. But in that case, you need to have a second disparate data center, or think about using a cloud provider. This second data center concept is something we're going to talk a lot about in this session. This is where the cloud can be a really good solution for many people. So in this case, if we lose the SAN, or we lose our connection to the SAN, or anything bad happens, we lose our whole cluster. Everything goes down in that scenario. So just because you have a cluster doesn't mean you're completely protected. Also, most importantly, and this won't be the last time I mention this today, but remember, all good disaster recovery solutions include a solid backup, and more importantly, recovery strategy. For companies with limited on-site resources, this can be a really good use of cloud resources. You can ship your backups to a cloud provider. If you're on SQL 2012, SP1, CD2, or higher, you have built in the ability to back up to Microsoft Azure. If you're on 2014 or higher, you have a feature called Manage Backup that will just automatically back up to Azure for you. Being able to back up to a second location, and more importantly, being able to test those restores are really important. And that's cloud backup is a really cost-effective way to do that. So just to review some disaster recovery terms, when you get started working on your disaster recovery plan, there are a few things you need to know. Depending on the size of your company and the nature of your business, this can be pretty complicated. Even with a medium-sized business, you're really going to want to split systems into criticality. When you're really small, you mainly have 1 or 2 systems. I know our company is pretty small, and really we don't have too many systems. We can live with that. But as you grow, you become more dependent on business systems. So you'll want to split those systems based on a criticality. And the way you determine criticality when you're doing a disaster recovery plan are 2 things, and that's recovery time objective and recovery point objective. Recovery time objective is how long your systems can be down before your company starts losing money. For a customer-facing e-commerce site, say Amazon.com, this is basically instantly. If they're down, they're losing money. So you're going to want to dedicate a lot of DR resources to that system. You're going to want to have multiple secondaries in multiple environments. That's a really important system. However, if you're Amazon and you have a back office HR reporting system, you can probably take a couple of days to get that back online, and it won't impact as much. So you probably wouldn't use something like clustering or stretch clustering on a system like that. Recovery point objective aligns with this pretty closely. Recovery point objective is how much data you can lose before the business is impacted. I know as database admins, we always want to lose as little data as we humanly can, because I always felt like it was my job to maintain the protection of the data. But you can start, in some systems, you can lose a little bit of data. If the last set of data doesn't make it into the database, the system can go on. In most of my experience doing this work, I've grouped systems into tiers, usually 3 or 4 different tiers depending on application needs. And this is a really good first step DR exercise to do. Even if you're not planning on implementing any DR or HA into your environment, it just gives you an idea of which systems are the most critical to recover. And realistically, when you're doing these things, you need to do it with executives and get executive sign-off, because you don't want the CEO yelling at you when the hurricane's happening. You want him to have yelled at you in the meeting where he signed the document that said which system was important. So one more thing about myself, I really like auto racing, Formula 1 specifically, and I just think it's a really interesting use of technology. And I've always seen this quote used in terms of racing, and I think it's a great quote to apply in terms of IT. How fast do you want to go? How much do you want to spend? The car here is the Red Bull RB8. It won the Drivers and Constructors Championship in Formula One in 2014. It's custom developed for each race. It can corner with a force 4 times of gravity, and the team has a budget of about $400 million a year just to build 2 of these cars and race them 22 cities around the world. The second car is a Tata. It's an Indian car that costs less than $5,000. Its top speed is under 70 miles an hour. I use both of these illustrations to demonstrate something. Both of these vehicles can get you from point A to point B, just in a highly different fashion. Some businesses will build extremely available systems with multi-site clusters and tertiary systems and cloud backends, while other companies might feel comfortable shipping their backups off-site. It's really just going to depend. But you can, and what we're going to talk about specifically when we get to the cloud kind of democratizes everything. A lot of things we used to do in the past that would have required a great deal of expense, like multiple data centers and really expensive SAN technology, we can do on a much lower budget. So we'll talk about that shortly. Quick poll, do you have a written disaster recovery plan? And Greg, can you go ahead and launch that?
Yep, so that's out there. So everybody can just kind of respond to this poll, and then we'll share the results. About half the people voted so far. I'll give it another 15 seconds, and we'll close this and show the results. All right, get those votes in, and I'm going to close it. All right, let me share the results. So we have 67% said yes, and 33% said no.
Yeah, I think we're a little bit self-selecting in a DR session that people tend to have an interest in DR. That's a pretty good number. So we talked a decent amount about DR plans, but how you need to start with RPO and RTO. After you've made these decisions, you should really write everything down. So which systems are important, and they should be made on that business systems level, because that's how you're going to restore things. And really, I know we're focused on databases here, but you also need to think about the application tiers and what you need to do with that. Application servers tend to be a little bit easier to deal with because they don't require integrity, but that's definitely something to think of. Your technology decision should be driven by these RPO and RTO metrics. I know I've been guilty in the past because I was trying to learn stuff of implementing pretty complex DR solutions. I may have implemented mirroring on a system that really didn't need it, so I can learn mirroring way back when. But realistically, your technology decision should be driven by your RPO and RTO. Write everything down, have a complete DR plan, and most importantly, get executive sign-off. This isn't something you can do purely within IT. You want to have outside of IT be aware of this so that they're involved and they know what's going to happen if something goes truly wrong. And then having a solid process. Your process is way more important than technology. And this is going to lead us to our next poll question, but you really need to test a lot. One of my former employers had a 55 terabyte database, and it did about 3 terabytes of transactions a day. And the applications team was complaining to us that they didn't have real-time DR. The reason why they didn't have real-time DR is it would have cost about $1 billion. I'm exaggerating slightly, but it would have cost a whole lot of money to do what they wanted to do. But we were in meetings with the team, and I was on an architectural team, and we were in meetings with that app team, and we asked them when was the last time they had tested a database restore, and the room pretty much went silent. And the answer was we hadn't, and the other DBA who was in the room and I both suggested they stop doing backups. Because it was a system where the data was reproducible, so kind of like a data warehouse, not exactly. The team was shocked when we said that, but we were serious. You really need to test restores on a regular basis, and think about some other things that are part of your uptime. Another really important thing to think about for protecting your data is consistency checks. I mean, consistency checks are almost as important as doing restores. So DBCC CheckDB needs to be run on a regular basis. I worked with a customer who had a 130 gig database. they were actually, the sad part is they were running CheckDB on a regular basis. Nobody was checking the output. And their backup retention window was only 7 days, and like 14 days earlier, CheckDB had found corruption in the database. So they were pretty much hosed. There was no way around that. So those are some of the other things you need to think about for uptime. Backing up your data, not enough. Regularly test recovery. Really great use case for PowerShell, really great use case for Azure. You can back up to Azure, spin up a VM, test the restore, and then spin it back down. So really cost-effective way to do that. And then send your backups to multiple locations. I know in the past, everyone used to use IronMem. What I tell everybody now is send your backups to Azure. It's so much easier. Or Amazon if that's your flavor, but Azure's built in the SQL Server. You don't really have to do too much. So quick next poll, have you tested your DR plan? And for those of you who don't have DR plans, did you do a test restore in the last year?
We got about half the people voted so far. We'll just let it go another 15 seconds or so. All right, get those final votes in. I'm going to close this and share this. Okay. So we have 77% said yes and 23% said no.
I'm impressed. You guys were way better than my average SQL Saturday audience. Usually that poll's about the inverse of that. So why go to the cloud? We've talked a lot about the logistics of DR and that are required for a good DR plan. And traditionally, these weren't available to a lot of smaller companies. Things like redundant SANs and data centers were extremely expensive, and many of those resources would sit idle most of the time. When I worked for the big cable company in Philadelphia that I used to work for, we had 3 major data centers, 3 full-on big-time data centers, and several smaller satellite operations. This made DR a lot easier. However, most companies don't have solutions like this, nor do they have operations teams to manage a second site because you're talking more people. And many small organizations have no real option, especially if they're hosting their own data center. If a disaster were to hit, they'd be in real trouble. So the redundancy there is definitely something to think of. Many smaller orgs don't have any near real-time DR at all. I will admit, and we were talking a little bit about this before you guys came into the webinar offline amongst ourselves, about the cloud's not for everyone or every system. Some firms have security concerns. I think most of those have been abutted by Microsoft. There's a decent number of they meet almost every audit standard I can think of, and frankly, from what I know about their security, their data centers are probably more secure than any other data center I've ever worked with. So the security is not so much a concern. But the one thing I will say is, and this is something to bear in mind when talking about the cloud, the cost can be kind of high. So and this is particularly on very big systems. I think the costs are very cost effective, especially on the lower end, and you're not paying for a data center or power or anything like that. But on the high end, so the GS5 VM, which is the biggest VM you can run SQL Server on, it has around 500 gig of RAM. I think it's 440. I think it's 500 gig of RAM and 32 cores. Just the compute on that VM, assuming you brought your own SQL Server license, is about $9,000 a month. That adds up pretty fast. So if you're talking about moving a bunch of big systems, it may not be cost effective. Where the cloud really shines is on smaller systems and on systems that have a high degree of variability. So if you only need that big VM, for a month of the year and you're a retailer, that's a great use case. But if you need a big system all the time, you want to definitely be careful with the numbers because they may not work out in your favor. So one last poll. I'll stop hammering you guys with these. They were kind of front-loaded. How many data centers do you have in your environment? And this is, don't count cloud if you're using cloud in this number. I'm going to go with 2 at like 50%. I'm not seeing the poll. I'm seeing the poll, Greg. I'm not seeing the results. I'm guessing based on our other questions. This audience seems to be pretty DR focused. So I think most of them will have 2.
All right, we'll see if your prediction is correct. We'll give it another 15 seconds here and we'll close this out. We've got a pretty good amount of the audience already voted. All right, any last votes? All right, let's close this and share this one. And we have 22% said 1, 53% said 2, you're right on, and 25% was 3 or more.
And I'm looking down my notes at you folks with one data center. I think you're the same 22% who aren't testing your DR plans because you can't. So particularly for you 22% who have one data center, let's talk about the cloud. So we're going to jump right into talking about Azure. I'm going to start talking about some terms, and these things are a lot of the nuance around using the cloud, and in this case, we're going to specifically talk about Azure over EC2. But there's a lot of nuance in networking in the way storage works. Those are really the two big things that are really different from that separate running SQL Server in a VM in Microsoft Azure and running SQL Server on a server in your own environment. One of the things we have here is called an endpoint. An endpoint's a port mapping that's going to allow communication. So really this is a hole in a firewall, effectively, from outside of Azure to inside of Azure. So how you'd configure this in your environment would be, if you wanted traffic just to go over 1433 from your company's IP address, you'd open 1433 to that IP address. Realistically, what you're going to want to do is, if you're using Azure on any sort of regular basis, establish a VPN connection. And that's going to lead us to our next term, which is a gateway. And this is a network component that allows you to enable hybrid architecture to provide VPN connectivity to your Azure resources from an on-prem environment. I'll basically come out and say it's really a necessity to have a VPN if you're doing any substantial level of DR at all. It's just easy. It's not a big expense. You can have it for as low as $30 a month. You can spend more than that and get better performance. But it's kind of like trying to run a SQL Server environment without AD. You want to have AD. So you also want to have a domain controller. If you're running resources in Azure, you definitely want to have a domain controller there, especially in a hybrid model, just because if your connection gets broken, you want to be able to do authentication and not have all the other things that go wrong without AD. Next is a virtual network, and a virtual network is just a VNET, so it's a container for your VMs. It's going to be required for always-on hybrid. It's going to be required for a data keeper cluster. Any of these things are going to require a network. One thing to note, and I have a little bit about it on a slide later, all your IPs in Azure are going to appear from your servers to be dynamic IPs. So you set your IP reservations either through PowerShell or in the portal, and that's how you can control it. You're not really going to use the network settings feature in Windows. A couple of other terms. Affinity groups are a way that you can group together your cloud services in proximity to each other in an Azure data center to try to achieve optimal performance. What this means is basically, if you have an app server and a database server, you're gonna make your app server be maybe in the same rack or close to the same rack as your database server, so you're not traversing all the way across the data center from a network perspective to get there. Typically, that'll reduce latency and increase performance. Availability sets are somewhat of a similar concept, but a little bit different. Availability sets are almost like anti-affinity in VMware, if we think about that. And what anti-affinity is, if you're not familiar with it, is it helps, I feel like, and I'll step back a second from availability sets, it helps to think of Azure as just a giant VM farm that you're running in, because that's really all it is. It's Microsoft's giant VM farm. It's got a bunch of cool automation features, but it's really not that different from the VM farm you may have it in your on-prem environment. And simply what availability sets are is, if you're doing any sort of high availability and virtualization, you should always have rules set up so that your two VMs are never running on the same physical machines that are members of your cluster. because if they are, and your host goes down, has bad memory or something like that, you lose both of your VMs and all of your availability is gone. So this is simply what availability sets are, setting up anti-affinity rules. Another interesting thing, and I don't like the way Microsoft named this feature, is a local network, and this is a special VNet to VNet connection. So VNets are within a single Azure region. Microsoft likes to use the term region. I still prefer data center. They pretty much mean the same thing effectively. And this allows two VNets that are in two different regions to talk to each other. So this is how you can set up multi-site failover within Azure. So good thing to know about. And then finally, and this one's particularly important when we talk about clustering or availability groups, you need a cloud service. And this is just a service. It's just a virtual container that contains your machine. The important thing to note is the way we're going to connect to our cluster or your availability group, if you're using that technology, is through what's known as an internal load balancer. It's a network connection, and that's how you're going to make the connection. You can only have one of those per cloud service, so you'll want to contain your cluster within a given cloud service. So site-to-site VPN, this is probably the easiest way to get started with a VPN connection to Azure. And I need to update this slide because it still says Windows Azure. Microsoft changed the branding on that a while back. But here you have an on-prem environment with a SQL server and a domain controller. In your DMZ, you're going to have a VPN appliance. There's an approved list of VPN appliances, or you can use Windows Server to use RRAS, which is Remote Routing and Access Services, I think. Dave, correct me if I'm wrong. To make a connection to Azure, and that's where that gateway we talked about is going to come in. So you can see the gateway on the screen there. That's going to give you a public IP address that only your VPN can connect to, and that's going to bring you into Azure. And then once this is created from a perspective of a database, you're really not even necessarily going to know if you're in Azure or if you're on-prem. You're just going to see a different machine on a different subnet. There's a couple of subtle things you can look for, but there's nothing major to show that. ExpressRoute is just a really fancy version of that site-to-site VPN. What's cool about ExpressRoute and why it's good if you're using SQL strategies is it gives you a dedicated connection. So as opposed to just being a private connection over the internet like the VPN is, this is a part of a dedicated line. So you're going to get a port speed that's going to take you directly into an Azure data center. And so these can be cheap on the low end. So we see, to get a gig line, it's $600 a month. So that's not too bad. On the high end, it's very expensive. But these are the connections you're going to want between your on-prem and your data center, particularly for your Azure data center. In your on-prem environment, particularly if you're doing, a whole lot of stuff. The site-to-site VPN is fine. If you're just, maybe log shipping or have a small cluster that you're working with, and you're talking about one system. But if you're talking about multiple systems and Azure is becoming a big part of your business, you're definitely going to want to get on the Express route. It's a really powerful technology. So IP addresses. Azure VMs have both a public and private IP address. This is important to know. And always double check, because Microsoft a couple of times has done this, especially if you're using the SQL Server templates, as opposed to building a Windows server and installing SQL on it. From time to time, somebody's decided it's been a good idea to open 1433 to the internet. I think they mostly have that fixed now, but just always take a look. And bad things happen when you open 1433 on a public IP. You'll start noticing lots of failed SA logins in your log coming from all sorts of interesting countries. I had that happen a couple of times. It's the only reason why it's so fresh in my mind. But you do have a private and a public IP address, so you can initially connect over the public until you get it into your domain and get all that naming stuff configured and get DNS configured. You're going to configure your DNS and your reservation through the portal. This is much easier to, actually, you can do this in the new portal. If you're using the old portal, which is at manage.windowsazure.com, you should really move on to portal.azure.com. It's a little frustrating. There are some things that are a little annoying about the new portal, but almost all of the functionality is built into it. In the past, if you wanted to have an IP reservation, it had to be all done through PowerShell. Now you can simply do it in the portal, so that makes it a lot easier. You also set the DNS server for your network in the portal. So what that means is if you're doing DNS through your domain controller, which is the most common scenario I see with Windows environments, you'll give in the portal you'll supply the address of that domain controller, and then realistically you can kind of let everything else run on dynamic IP. I still prefer static IPs myself, but I'm kind of old school that way. Initially, we can only have one IP address on our Azure VM. Now they can have multiple IP addresses. One other thing I'll mention that I didn't have anywhere else, the size of your network bandwidth, and in particular the storage bandwidth you get, is directly tied to the size of your VM, and it's documented somewhere. So if you were to Google, Azure VM network throughput or storage throughput, Microsoft has that documented for which size VM gets how much throughput. So that's just something to keep in mind. So let's talk about some high availability options in Azure. Our typical go-to option is for high availability in the SQL Server world that's been around forever, failover clustering, but we'll talk a little bit about availability groups because failover clustering is going to require data keeper. Availability groups are going to require an enterprise edition. So a little bit of a trade-off there. I know the data keeper standard edition option is still a lot cheaper, but let's talk about the pros and cons of each. So always-on availability groups, as you remember, introduced in SQL 2012, built on top of Windows clustering using standalone instances. We connect to these using a listener name. We have this concept of an availability group. So an availability group is just a set of databases. This is not. There's a few challenges here. So jobs and users don't necessarily migrate across the availability group. We can span multiple locations with an availability group quite easy, and this works pretty much the same way in Azure. Really, the only difference within Azure is that our listener name, as opposed to just being an IP address, has to be configured as an internal load balancer. The clustering is going to work fairly similar to that, not too different at all. But this technology continues into 2014 and into 2016. There's some back-end changes in 2016, but fundamentally everything still works the same way. So there are a decent number of pros here. So we have readable secondaries that we can allow for load distribution. We have no shared storage, so we can reduce hardware costs. Multiple databases failing together is good for complex apps. The listener gracefully handles our connection string. And really the big difference here from an administration perspective is it's all done through SSMS as opposed to using Failover Cluster Manager. I don't think that's too big of a deal. Most DBAs are pretty comfortable with Failover Cluster Manager. The cons are there's large topologies, so if we start talking about having multiple secondaries can lead to high license costs. More importantly, it is enterprise edition only. And this can be very challenging under high workloads. And this is something that's getting improved for 2016, definitely. The code stack for log transfer is rewritten, but I was dealing with it this very morning at a client where we had an availability group, and they were pushing a big job through on the primary, and my secondary replicas kept falling behind, catch up, fall behind, catch up, fall behind. The reason for that is right now the redo stack. So when the transaction logs go to the secondary, and then the redo gets applied to the secondary replica, that's just a single-threaded process. So that can be really challenging to maintain, especially if you're using synchronous availability groups, which is what you need to do to have automatic failover. Users and jobs need to be maintained. Microsoft did introduce contained databases, which allow users to be contained with the database. This works great for Windows users in the availability group. It does not work so well for SQL users. I know generally speaking, we should always use Windows users, but Unfortunately, the folks who wrote Dynamics GP didn't agree with me on that, and they use SQL users. So Dynamics GP has multiple databases. They're in an availability group. We can't have contained database users. Contained database users are at the scope of the database. They're not at the scope of the availability group. So there's no way to. They'd have to have multiple passwords, and that's just an ugly process. Likewise, jobs need to be maintained because jobs don't travel. MSDB is not part of the availability group. And frequently, you need to change your application code to deal with some of the failovers. So those are really the challenges around always-on availability groups. And here's kind of our example of how we do a failover cluster within Azure using SIOS DataKeeper. Here, a lot of things you'll see that are similar to always-on availability groups. Here we have a cluster name, and that's going to be our connection. That's also an Active Directory virtual computer object, our SQL Server cluster name. We have a SQL Server instance running on Node A, and then we have Node B. I know we talked a little bit earlier about how traditionally clustering without SAN replication is, just a high availability feature. It doesn't give us disaster recovery protection. With DataKeeper, and the way DataKeeper works, it's a block level replication technology. So if you're in synchronous mode in DataKeeper, a write isn't going to get acknowledged to the operating system from the storage device until it reaches the secondary replica of the storage. So much like really any async sync technology, you're going to want low latency if you're going to be in synchronous mode. So that's something to be aware of. But if you're within the same data center, in this case, you can go synchronous, and this works just like clustering. It's really just like SAN replication at a much lower cost. So when we fail over, the service is going to come back up on that node B, and it's going to be connected to the second node, or the second set of storage, and then the storage is going to start back, going back to node A storage. So we have data protection here. And so the way this works, just another graphic. If we lose this node, the service moves over. This is a block level replication. So unlike always on, where we're having to apply redo logs to the secondary, all we're doing here is writing the ones and zeros that can run into the disk, which is a much more efficient process than having to do that redo apply configuration of. It's a 7-step process to move data in an availability group. It's far less complicated here. So failover clusters instances in Azure. This is a fully supported feature by Microsoft. SIOS got approval from Microsoft to do it. It's the only way to do clustering, SQL Server failover clustering within Azure. It's a really easy deployment, and I know these guys are working on making it even easier. More important things, clustering is just a really, really robust technology. Clustering's been around since SQL 7. I don't really think it worked in SQL 7, but it did start working in SQL 2000. So we have a single instance. So as opposed to having our unit of failover be our data at the database level or the group of databases level, where we don't necessarily maintain all of our users and we don't get any of our jobs and logins are going to transfer with a failover. So this is ideal. More importantly, it's supported on Standard Edition with a single connection string. There are a lot of other technologies in SQL Server you can use to protect your data. You can use replication. You can use log shipping. Log shipping is typically my preference on Standard Edition. But the thing log shipping doesn't give you is a single connection string that deals with failover gracefully. So if your application needs to be up all the time and you have to failover log shipping, you're going to, even if you're using CNAMEs, you're still going to have to change an IP address. Lots of challenges with clustering. It's either a single IP address or 2 IP addresses that fail over. It's just very easy. And more importantly, with the cool thing about Azure and DataKeeper is you're triply protected, because every disk you have in Azure, Microsoft maintains at least 3 local copies of. That's kind of an important thing to know. But remember, you can still have corruption in their data center. Always do check DB. And in this case, you have those 3 copies and then a second 3 copies since you're using another VM that has another copy of your data. Obviously, this doesn't completely protect you from the user who deletes a million rows, but that's why backups are so important. Those are the things we have to do. We can also easily span data centers with this scenario. So this is kind of how our VNet to VNet works. This is a fairly complex infrastructure that I plucked out of books online with the Contoso company, where they have a North American headquarters that has a data center, and then they have an East Asia data center. And they have VPN connections direct from each site to each Azure data center that are represented by our clouds there. But what you can do is do VNet to VNet connectivity, and this is going to allow you cross-region geo-redundancy and geo-presence. You can set up your own geo-replication building your clusters out that way, and you can do it securely without going over any internet endpoint. So this is the really fantastic thing for those of you who maybe only have 2 data centers, maybe only have 1. You can build this sort of environment within Azure. And the other thing that I like to always note when I'm talking about DR in the cloud is that if you go back and look at the history of Azure outages and the history of Amazon AWS outages, most of the time, I know there was one really bad one that took the whole service down. Most of the time, those outages are limited to 1 data center. So if you're protecting your systems across multiple Azure data centers, especially with clustering and clustering and disk-based replication, you can really have you can really get close to 4 or 5 nines of uptime if you're good with your process. So you can build the solutions that would have cost millions of dollars years ago at a much lower cost now. And then finally, and here's how that would look across fault domains with Azure. This just showcases Azure West, but it shows the solution is definitely certified in Azure. This can easily, especially in asynchronous mode, span data centers. I know I've configured it that way for several customers where we've gone across multiple Azure data centers, all using standard edition. And here we show a file share witness, and one thing I'd like to point out, which is one of my favorite features I just got finished writing about Windows Server 2016 for the new SQL Server book chapter that I finished. And Windows Server 2016 introduces this concept of a cloud witness. So one of the traditional challenges is in any disaster recovery scenario that involved Windows clustering was which data center, if you only have 2, do you put the witness in? And Microsoft's recommendation was always to have a 3rd data center, which when I worked at Comcast was really easy. When I worked at other places, not so much. It's kind of complicated. You get the ability to have a cloud witness, and all it is a file in Azure Blob Storage, but it's a fantastic solution for that problem. There are also a few other pretty cool features in Windows Server 2016 that I'll mention quickly since we have a few minutes. There is site-aware failover, so you can have all the failures be within a given site at a given time. So that one's also going to be, I think, pretty nifty for SQL Server. And you're going to be able to do rolling upgrades to Windows Server 2016 in clusters. So traditionally, when we had clustering, we had to build a new cluster in order to upgrade the OS. Now we can do a rolling upgrade from 2012 R2 to 2016. I think that's going to be a really big win for a lot of customers. So in summary, Microsoft Azure virtual machines and storage offer the same HA and DR options that we have on site. We can do clustering, we can do AGs. I didn't talk too much about it, but one thing you can do if you want to build this out in a test environment is build a point-to-site VPN. If you go to my blog and search on point-to-site VPN, I have instructions on how to set this up. Provider Connect, Express Route, that's really the way to go to make networking easier. And this is a great model. This cloud model is a great model, not just for smaller shops, but really for everybody. If you have critical systems and you want to supply disaster recovery protection to them, it's really a great model. And SIOS Datakeeper is really great software for doing that and building a high availability solution into the cloud. So Greg, do we have any questions?
Yep, there's actually a few questions. So one question that somebody asked was about they're not using Azure at all right now, and their company is just doing everything on-prem. And I'm just wondering, what's the easy way to kind of get started with Azure, and does it cost much money to kind of start, fooling around with Azure to get some experience?
Yeah, that's a really good question. So first of all, I'll mention that if you're lucky enough to have an MSDN account, depending on your level of MSDN account, you get somewhere in the U.S. between $50 and $150 a month of Azure credit to play with. That's pretty cost effective there. The other thing, there's a free trial account that they'll give you $200 of credit that you can use for a while. In terms of getting comfortable and what to play with, I'd really recommend building a VNET and getting comfortable with the networking. I think that's probably one of the bigger challenges. The networking it's not hard, it's just really different from traditional networking, and getting comfortable with those concepts are really the key. I mean, you can go and once you build out your networking, you can build out a VM and play around with SQL. One thing I'll mention, while 2016 is in preview mode, if you build out a VM with the SQL 2016 template, you're only getting charged for the compute. You're not getting charged for the SQL licensing. Actually, that brings me up to a point I wanted to make earlier that I forgot. We're still waiting on an official document from Microsoft on this, but it is definitely official. Just a quick licensing point. In the past, all DR, well, and it's still currently, all DR systems, if you have SQL Server and you have software assurance, you always got to run a DR copy of your SQL Server for free. The software assurance came in with SQL 2014, but unfortunately, there was no mechanism for them to do that in Azure. So if you did it in Azure, you had to bring your own license in order to get that free secondary. And bringing your own license means you didn't get to use the Microsoft templates, which just added a lot of complexity to the process. Microsoft has adjusted that. And Dave, Birmingham, have you heard anything on the mechanics of that yet?
No, I've been kind of communicating with some product managers at Microsoft, and they recognize the problem, so I'm hopeful that they'll be able to address that, but there's nothing official. So
okay.
Yeah, you got to bring your own license to take advantage of that currently.
Cool. All right, Greg, next questions.
All right, the next question is related to the SIOS Datakeeper product, and the person just wondering, is there a way to get a trial edition or a way to test that in their environment?
I'll let Dave hit that one.
Yeah, absolutely. We have, if you visit our website, we can get you a typical trial, 14-day trial key, and, you'll have support, pre-sale support, so someone like myself will answer any questions you have. And, if you like what you see, converting your trial to a full production is just replacing the license key, so it's simple to go from trial to production. So definitely, there'll be some contact information we can send out to you, or visit our website. We definitely get you started with the trial.
Okay.
Cool.
The next question, Joey, is related to storing the backups on Azure that you mentioned kind of earlier in the slide deck. And somebody just wondering, is that something that's easy to implement to just push your backups up to the Azure storage?
Yeah, so I can go into a little more detail on that. This feature was introduced in SQL Server 2012, Service Pack 1, Cumulative Update 2. I should have that build number committed to memory, but I don't. So if you're on any version of SQL Server higher than that, it's fully supported. I have a couple of blog posts at my blog on how to do it, but it's real simple. You need a couple of things. You need a storage account in Azure. And once you have that, you'll have what's known as a container and a secret key. So the container is just really a folder within that storage account, effectively. And the secret key is just a password to access that folder. With those two items, you will create a credential within SQL Server. So you'll create a credential for SQL Server to use. And then after that, you can simply back up to use the syntax backup database to URL, and that'll be the URL of your storage account, which will be yourstorageaccount.windows.blob.net, I think, or .blob.windows.net. And you'll say backup to URL, that URL with credential. There are certain options that you can't use. Before 2016, you can't go to multiple files, but you can use that straight away. It's just part of the basic backup syntax that SQL Server uses. In SQL Server 2014, Microsoft introduced a new feature, and you still have to do that setup, that credential setup. So you still have to have the storage account and set up your credential. But they introduced a feature called Manage Backup to Azure. And with Manage Backup to Azure, all you do is set a retention period on your data. And SQL Server will then handle, once you configure Manage Backup, and it's in the GUI, and you can configure it there. Manage Backup will maintain backups of all your databases, and that if you set it for the instance or if you set it for a database, it'll handle that database, and it'll handle transaction log backups and fulls based on your transactional activity. I think their algorithm is to back up the transaction log every 15 minutes or every gig of transaction log activity. So that's built into 2014. The processes improve a little bit in 2016. They just become more robust and can deal with larger databases and things like that. So that feature is definitely enhanced. I think that's, and then finally in 2014, you can encrypt your backups in all editions of SQL Server. So if you're using 2012, the only way you can have encrypted backups is if you turn TDE on, transparent data encryption. In 2014, you can just encrypt the backups without having to back up your data files.
Okay, great.
Okay.
The next question is related to doing DR up on Azure or up in the cloud, so keeping their primary data center on-prem and setting up DR in the cloud. And just wondering two things. One is, how hard is that to actually implement? And number two, are there any white papers or articles out there that you recommend people getting more information about that?
So if you have access to the past summit videos from 2014, I did a 3-hour session on that there. There's a company called Opsgility that's a little bit like Pluralsight, but for Azure. I've got a course on SQL Server DR in Azure there. Realistically, the challenging thing with that is getting your network configured. Once you have the network configured, it's really just like going to another data center. So it's really working with your networking team to ensure that your connectivity is good. Aside from that, the other two, the three major recommendations I have are have a VPN. Ideally, have ExpressRoute. I think it's worth paying for just for the simplicity. Have a domain controller within Azure, just because if you do lose your primary site, you still want to be able to authenticate and all that. And then use whatever technology you want to use for that. DataKeeper is a great way to do it cheaply. Availability groups have some stuff built in that make deployment somewhat easier. The two really tricky things there in the network, and then is configuring and network. They're really all networking, because the other ones you need to configure an internal load balancer for your cluster connection. So.
Okay, great. We'll take one more question. We're just about out of time here, and this goes back to the security issues you were talking about earlier in the presentation, and just wondering, are there any special security concerns that people should be aware of when going to the cloud? Is it anything that you've come across that kind of?
Yeah, I think the cloud's just as secure as anything you can do on-prem, but it can be just as insecure as anything you can do on-prem. So if you do something stupid, like I've done in the past and had 1433 open to the internet, bad things are going to happen. But really, just think of it as a second data center, and having a VPN in place means you can shut off really all public ports, and you don't have to worry about anything external. And if your auditors are concerned, just Google either Microsoft Azure audit specifications or Amazon AWS audit specifications. Those guys are pretty on top of this stuff, because let's face it, lots of government agencies are using the cloud now, so they're secure. But in terms of Any real specific things? No, I think it's pretty much the same as on-prem.
Okay, great. Thanks, Joey. All right, well, actually, just out of time here, so I want to thank Joey for sharing all that great information, and also want to thank SIOS for sponsoring today's event. As you can see on the slide that Joey has up, here's some links to more information, so please check out all those. And also, the webcast was recorded, and you'll receive a follow-up email with links to view the archive as well as download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux. Thanks for attending, and have a great day.